Hi viewers, I am producing these videos to support teachers of mathematics in helping their learners make sense of mathematical concepts and their associated procedures and processes. And today what I want to look at is multiplying larger numbers, so numbers with more than one place value column. And to do that, I'm going to be using some Deans and also some Quizonaire, and then eventually a nice tool on one of my favorite websites, mathspot.com. More about that later, to look at even larger numbers in terms of area. So let's have a look at say a larger number multiplication, a multiplication that involves numbers with more than one place value. So maybe something like 23 times 14. And so what I'm going to do here is I'm going to use an area model for this multiplication, and I've got my Dean's blocks to help me with that. Now, obviously, if you were using Dean's in as a concrete manipulative, you would use those in 3D. But as I'm just going to be relying on the hundreds and no more than that in a minute, I'm going to make them 2D just to make them a little easier to see. So here is my 20, well, that's 10. So I'm going to set up my number 23. And then I'm going to create another rectangle. I'm going to create the width of that rectangle to have a width of 14. So this is my model for 23 times 14. It's create a rectangle with a length of 23 and a width of 14 that has no gaps, no overlaps within it. And so the job for the pupil now is, okay, can you tile this space? And of course I could tile this space with a load of 10 rods. So I could set some 10 rods going all the way across there. But actually it would make more sense here to say, right, well, I'm going to put a 100 rod in there and I'm going to put a 100 block in there. So here is 200. And then for these ones, I'm definitely going to use a 10 block. So I'm going to put some 10s blocks in here. And then similarly, I'm going to put some 10s blocks down here. And then in this little space down here, of course, I'm going to have to put some 1s. And so the question is, how much do I have altogether? Well, you can see I've got 12 1s. So actually, I could exchange those for a 10 and 2 1s. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 10s. And so I could exchange 10 of those for 100 and then leave myself 110. And then I've got 200s. But what I might do, of course, is I might draw a picture of that. I say I've created this rectangle which has a length of 23 and a width of 14, but I can see that actually what I've done here is I've created it in 4 parts. And this top left part is where I've got my 20 by 10, so that's 20 by 10. And in there I've used 200s, so that was 200. And here I've got my 3 by 10 part. So here is a 3, and there's my 23, 3 by 10 part, which is giving me 30, using 3 10s. And here I've got a 20 by 4 part for this bit here. So that is my 4, and I've gone 20 by 4, and that's used 8 10s, so that's 80. And then, of course, I've got my 3 by 4 rectangle in the bottom corner, and 3 by 4 is 12. So to evaluate that multiplication, I'm going to need to add up these 4 parts. Okay, and that's what, of course, is linked to the grid method for multiplying multiplying numbers, sorry. But we can see that that comes from an area model, and I can actually build those areas before I start drawing these pictures. Now, if we want to sort of partially abstract that, then we might do something similar with Quizonaire. And we can see here we've got Quizonaire, so I can build the same things. 20 3, and this is of course assuming the white rod is 1, just in the same way as before on the Deans we assumed the yellow block was worth 1. And here's my 14 being built as 10 and 4. And now again I could use rods to tile this space, but I have to use lots of 10 rods here and then some more 10 rods here. But actually, because I'm showing this with the grid on, and obviously I could hide the grid, but I want to show the grid, we can sort of do this visually using the same idea as this, but actually being able to see the squares. So I can see here that I've got a 10 by 10 square, so that's 100, and then I've got another 10 by 10, so that's 200, and then I've got a 3 by 10, so I could actually make out the squares there, and I could see how I'm creating those individual rectangles and can evaluate how many squares are in each of those rectangles. And then that leads us to the third one, which is something like this. So again, I can do here 23 times 14. And this is, of course, a very visual sort of idea, which mirrors this grid. But actually, again, the point about this is you can physically see the squares. But with the benefit with this, which you don't have with the Cuisenaire, is you can see the demarcations. So you can see where it's 20 and then separately to that 3, you can see 10 and 4, and you can see here we've got our 10 by 20 rectangle, which contains obviously 20 columns of 10 or 10 rows of 20. And so we'll have 200 squares in, and then similarly 3 columns of 10 or 10 rows of 3 for 30, and so on and so on. And so sort of by transitioning to be able to fill these this grid and these areas up with my with my Dean's blocks, but of course, I would struggle to do 100 calculation with there, but I can actually fill these and see the separate spaces, to being able to sort of evaluate the separate spaces either using Cuisenaire or using the multiplication areas section. That can help me transition to seeing, oh well, actually, okay, well I'm just creating rectangles split into parts, and this is how many parts I've got, and I can work out the number of squares in each part separately, and by totaling them up, and again, what's nice with the multiplication areas is you can actually show the total, as well as being able to then start to go into the hundreds, which I can't do here because the 100 is an area in itself unless I do 10 tens along, which is going to get quite long. But I can actually go into my hundreds now and start looking at the different totals. I can see this is 1,000, this is 200, this is 30, this is 400, this is 80, and this is 12. So I can see my separate areas and what they're adding up to. Then that can be a nice way of sort of transitioning from concrete pictorial, partially abstracting as we go until we get to something like this. So that is my short video on sort of using area models and using manipulatives and visuals to support larger number multiplication. As always, I would like to say thank you to mathspot.com and its creator, Jonathan Hall, for providing such a wonderful website for teachers, which includes these virtual manipulatives, as well as other activities and tools that you can use, and a wealth of other things besides, all free, question generators, all sorts on there. And if you've never been to mathspot.com before, I would strongly recommend you go and have a look and see what it's got to offer for teachers of maths. And of course, if you are interested in seeing more about manipulatives and reading more about the use of manipulatives and images and visuals to support learners in making sense of mathematical concepts, then you can always check out my website, which is visiblemaths.co.uk. And on there, amongst the many things you'll find on there, one of the things you'll find on there is a link to my book. My book is Visible Maths. And on the website there is a link to the publisher, Crown House Publishing. And on their website, you can see some sample pages. And if you think it's going to be useful for you, you can, of course, place an order. I will be making these videos throughout lockdown and potentially even beyond. So if you have a particular concept or process or some mathematical idea that you feel it would be useful to see modeled using manipulatives and visuals, then please do get in touch and I will do my best to produce one for you. Thank you very much for your kind attention.